The shells are designated by letters K, L, M, N, O, P, and Q, starting with the shell nearest the nucleus. The K shell can contain up to 2 electrons. The L shell may contain up to 8 electrons. The M shell may contain up to 18 electrons. And the N shell up to 32 electrons. The maximum number of electrons a shell can hold may be calculated from the equation electrons in a shell equals 2 times n squared, where n equals the number of the shell with the inner or K shell being number 1, the L shell being number 2, and so on. For example, 2 times the third, or M shell, squared is equal to 18, the maximum number of electrons in that shell. These are the maximum number of electrons that a shell may hold. However, only the K and L shells must be filled before electrons enter the next outer shell. Beginning with shell M, electrons may enter the outer shell before the inner shell is filled to its maximum. This is important to know because the electron configuration of the element determines its properties. We are concerned with electron arrangement in the refineries and chemical plants because only the electrons of an element are involved in chemical change. In particular, the electrons in the outermost shell are affected during chemical change. Now open your workbook to exercise 4. In studying the composition of elements, you will learn that the electron configuration of an atom determines its properties. If you had to study the properties of the more than 104 elements in order to have even a basic knowledge of chemistry, you would face a formidable task. Fortunately, scientists found similarities in the properties of many elements and have been able to arrange them into a periodic table. This periodic table of the elements groups the elements according to similar electron structure. On the table are shown each element's atomic weight, atomic number, electron arrangement, and symbol. Let's take a close look at the information for one of the elements. This is the information given for calcium. In the center is the element's chemical symbol, Ca. Above the symbol is shown the element's atomic weight. For calcium, this is 40.08. In calculations, the atomic weight is frequently rounded off. Thus, the atomic weight normally used for calcium is 40. Below the symbol is given the element's atomic number, 20. In this column on the right-hand side of the symbol is shown the element's electron arrangement. You can see that calcium has 2 electrons in the K shell, 8 electrons in the L shell, 8 more in the M shell, and 2 in the N shell. In previous exercises, you have learned how to determine an atom's atomic weight, atomic number, and the atom's structure, but we haven't discussed atomic symbols. You can see how crowded this table would be if the names of all of the elements were spelled out. So scientists developed a symbol to represent each element. Let's take a look at the symbols for some of the more common elements. In the beginning, the first letter of the name of the element could be used for its symbol. Thus, oxygen is symbolized by the letter O. Hydrogen is represented by the letter H. And carbon is simply C. But since there are over 100 elements now known, and only 26 letters in our alphabet, the symbols for most elements must contain 2 letters. Thus, calcium is written Ca. And the symbol for cobalt is Co. The first letter of a symbol is always a capital, but the second letter is never capitalized. Returning to the periodic table, you will note that the elements are arranged in order of their increasing atomic number. The vertical columns are called groups, and all elements in a group generally have similar properties and contain the same number of electrons in their outermost shell. The inert gases are in group 8. Their outer electron shells are complete, making these elements stable, with no tendency to react with anything. The horizontal rows are called periods, and all elements in a given period have the same number of shells of electrons. The rare earth elements are extracted from the table and listed at the bottom. Now open your workbook to exercise 5. Now let's review some of the things we covered in Segment 1. In this segment, we have seen that matter is anything that has weight and occupies space. That elements are the basic materials from which all matter is made. That compounds are pure substances made up of 2 or more elements. They always have the same composition and same properties, and they cannot be broken down except by chemical means. That an organic compound contains carbon, while an inorganic compound is one which does not contain carbon. There are some exceptions. That a mixture is a material having no definite chemical composition, and which can be separated by physical means, such as boiling, filtering, etc. That atoms are the smallest particles of an element which can exist and still have the properties of the element. And that a molecule is the smallest particle of a compound which can exist and still have the properties of the compound. The major parts of an atom are the electrons, the neutrons, and protons. Electrons are tiny, almost weightless, negatively charged particles which revolve about, or orbit, the nucleus of an atom. Protons are particles 1,850 times heavier than electrons and have a positive charge. Neutrons are particles having the same weight as protons, but having no electrical charge. The protons and neutrons are packed in the center of an atom and form the nucleus. The atom is electrically neutral, since the positive protons and the negative electrons are equal in number. The atomic number represents the number of protons or electrons contained in an atom. The atomic weight of an atom is the sum of the weight of its protons and neutrons. Electrons orbit the nucleus of an atom in patterns called shells. These shells are designated K, L, M, N, O, P, and Q. The K shell can contain up to 2 electrons. The L shell may contain up to 8 electrons. The M shell may contain up to 18 electrons. And the N shell may contain up to 32 electrons. The equation for calculating the number of electrons in a shell is 2 times the shell number squared. The electron configuration of an element determines its properties. Only electrons are involved in chemical change. The electrons in the outermost shell are affected during chemical change. The periodic table groups the elements according to similar electron structure. Each element is assigned a block, and in the center of the block is the element's symbol. Let's take calcium as an example. Here you see Ca, the symbol for calcium. Above the symbol, you see the atomic weight, 40.08. Below the symbol is the element's atomic number. The number for calcium is 20. To the right of the symbol is the element's electron configuration. This example shows that calcium has 4 electron shells. Chemical symbols are a form of shorthand. The symbol for calcium is Ca, and the symbol for cobalt is Co. The first letter of a symbol is always a capital, but the second letter is never capitalized. On the table, the elements are arranged in order of their increasing atomic number. The vertical columns of elements are called groups. The horizontal rows are called periods. Now open your workbook to Exercise 6. This is a review of Segment 1.